Okay, welcome to the notes on Chapter 2, Section 1 and Chapter 2, Section 2. We'll go pretty fast through this, which is not a bad thing. It's a good thing. It means that you guys have a lot of these skills already. If I go over something too quickly, though, and you need help on it, make a note to yourself. Write down what your question is or what part of the notes you had a question on, and I will be sure to explain it further in class. But I can't answer the questions that you don't ask, all right? So remember to jot down your questions. We're going to look at writing equations today, and we're also going to look at solving one-step equations today, all right? So writing equations, we'll start there. Verbal expressions, we've already done. But now we're going to add this, this big giant word here, is, all right? When we see is, we're going to write that verbal expression, and we're going to make it into an equation that we can then solve. You guys have been doing this for a long time, since you were wee little children, all right? So for example, if we consider the Daytona 500, there was a brief story right here about the Daytona 500. It's the most widely considered to be the most important event in NASCAR. The distance around the track is 2.5 miles. The race is a total of 500 miles. How many laps does it take to finish the race? So if we consider that, each lap is 2.5 miles, multiplied by the number of laps that we don't know, and the length of the race is 500, we can set up this equation right here and solve. Okay, pretty self-explanatory. So the first part is translating into an equation. So we do that, and so that's step one. Not even solving, just translating. So let's, here we have 7 times the number. We've been doing this. This should seem like review stuff for you guys. So go ahead, take a second, pause the video here. Try these on your own. Pause the video, try these on your own, and then I will walk you through what the answers are. Try 1A and 1B. All right, so you've done the problems. Let's take a look at what I got. For the first one, 2 plus the quotient of a number in 8, that's n over 8, is the same as 16. So that's what I got for the first one. And then for the second one, 27 times k, 27k, equals h squared minus 9. That's what I got for mine. All right? If you have any questions on those, make sure you make note of it. Next, we're going to look at translating sentences to algebraic expressions and equations is a valuable skill in solving real-world problems. So this most often comes up, to be honest, in real-world problems, in application problems. So you're given an example of something, you set up an equation, and then you solve for some sort of missing information. All right? Checking your answer is a good idea to make sure you have it right. Never a bad thing to do there. So let's take a look at this example right here. It says, so we have 50 members in the North Carolina Senate, 70 fewer than the number in the North Carolina House. How many members are there in the North Carolina House? All right, so 50 members in the Senate. This is 70 fewer than the number in the House. So what can we do? Well, we have 50, okay, and that's going to be equal to the number of members in the House of Representatives in North Carolina minus 70. Pretty easy stuff here, okay? And then obviously for the answer we get 120. All right, so R equals 120. That's not a J, it's a semicolon. Lots of uses for that. A rule for the relationship between certain quantities is called a formula. You guys know all sorts of formulas from geometry, a lot of them. So the area of a triangle is 1/2 base times height, things like that, okay? So just working with formulas, translate the sentence into a formula. In a right triangle, the square of the measure of the hypotenuse, C, is equal to the sum of the squares of the measures of the legs, A and B, also known as the, did you say Pythagorean theorem? Because if you did, you were right. C squared equals A squared plus B squared. Pretty easy stuff, okay? You guys have been doing this for a while. Write sentences from equations. So same kind of thing that we've done in the past. We just need to be able to change the, we have this is now, or we can say equals for the equal sign. Go ahead and pause the video here. Try and do 4A and 4B, and then we'll check those. All right, so here are my answers. I got 15 is equal to the product of 25 and u squared plus 2, and 3/2 times r minus t cubed is the same as 132. If you're not sure if your answer is right, make a note and be sure to ask me in class and we can check it. All right. Writing a problem based on given information. So, for example, t is the time that Maxine drove in each turn. T plus 4 equals the time that Tia drove in each turn. So there's that. So Maxine and Tia went on a trip. So I'm giving you this information, and then you have to create a problem from that. All right? Not real complicated. It's just working backwards. We understand things better when we can do them both forwards and backwards. So if I tell you that Beth's salary is P, and her bonus is 0.1 P, what could this equation, how could you take this equation and then turn it into a problem? Okay? You know, you could put a variety of things. If you want to pause the video and try to answer that on your own or write one out and see what you get, that's fine. Go ahead and pause the video now. I'm going to share with you my answer. I would say that Beth gets paid. I would write out something like Beth gets paid at her job with both a base pay and a bonus based on her salary. Her bonus is 10% of her salary. Her paycheck last month was $525. How much is her base salary? So really simple, okay? Really simple. Just being able to work forwards and backwards. That's what we want you to be able to do there, all right? Moving on to solving one-step equations. So we've done all this writing of equations. We actually want to get to the point where we can solve equations. So off we go. We solve equations using addition and subtraction, multiplication and division. We'll start with the simple ones, addition and subtraction. You guys know the addition property of equality. We just may not always refer to it as that. But basically it works out as this, guys. What I do to one side, I must do to the other. Okay? If I add, for example, right here, if I have 14 on both sides of an equation, 14 equals 14, I add 3 to both sides, it's still 17 equals 17. It's still a true statement, okay? So as long as I do the same thing to both sides, I'm good to go. All right, so solving by adding. Some people like to work horizontally. I think people do better when they work vertically. You should work however you think you'll do best. But again, I'll tell you from my experience, people who work vertically do better. And I'll give you an example of what I mean by that right over here. So let's take a look at these examples and try these. Again, this is going to be simple stuff for a lot of you guys, which is a good thing. So if I have 113 equals g minus 25, I'm going to add 25 to both sides, all right, and I get 138 equals g. Same thing here. I have j minus 87. I'm going to add 87 to both sides. We want to get the variable by itself. That leaves me with j equals 84. All right, real simple stuff that you guys have done before. You're probably professionals at. Subtraction property of equality is the same thing. It's just the opposite direction. Instead of adding, I'm now subtracting from both sides of an equation. So let's take a look at these examples. Go ahead and pause the video. We'll try these on your own. Pause the video here. See if you get the same answers I get when you solve for k and p. Pause the video now. All right, so you've unpaused. Hopefully here you got k equals 3, and over here you got p equals negative 28. All right. If you didn't, try those again, and if you still don't, make sure you make note of it and ask me about it in class. The multiplication property of equality and the division property of equality, same kind of thing. They basically just say as long as you do it to one side, you have to do it to the other. That's all it is. It's about equal treatment. Not fair, but equal, because my dad always said fair didn't mean equal. All right, so for example here. Oh, let's make sure we see this. We want to know that when we solve equations, we can use the reciprocal a lot. And we know that from the multiplicative identity, okay? 2/3 q, if I multiply that by 3/2, I end up with 6 over 6, which is just 1 q, and that's what I want. So let's take a look over here. Let's solve 3a. If I multiply both sides of this equation by 5/3, I'm going to get, on this side, I end up with just with k, and over here, I end up with 10, all right? If you're not sure how I got 10, it's 6 times 5 over 3. Well, 6 times 5 is 30, and 30 over 3 is 10. So go ahead and pause the video here. Try 3b on your own and see what you get. Pause the video now. All right, I did it, and I got b equals negative 3/8. If you need help with that one, make note of it. We'll go over it in class. All right. Let's take a look at a real-world example. So real world example here on a group of 13 to 15-year-olds surveyed, 225 or about 9/20ths that they talk on the phone while they watch television. How many girls were surveyed? So we have 9/20ths, G equals 225, and we just solve. Real simple stuff, okay? Setting it up from the words and then solving. So if we take a look here, Allison is making, so what we need to do first here is we need to set up an equation. We have Allison is making a stained glass window, and her pattern requires that 1/5 of the glass should be blue. She has 288 square inches of blue glass. If she intends to use all of her blue glass, how much glass will she need? Well, 1/5 of all the glass would be blue, and blue is 288. All right, it's really just that simple. Go ahead and multiply both sides by 5, and we end up with G equals 1,440 square inches of glass. All right? That is it for the notes. What I'd like for you to do is I'd like for you to try some of these practice problems here. Some of these, and there's quite a few, but they're not going to take you long. Some of these, so if you want to pause the screen on these, try maybe just the odds or whatever, and we can check them in class. And then I'd like you to try some of these. Again, you don't have to do them all. Pick a hard one. Pick one that you think looks difficult or that you might not be good at. You don't probably need to do number 1. Just find some, do a few of them, and come to class with questions next time. I'll see you then. Bye.